How about we kick things off here? Yeah, first of all, I want to thank everyone for taking some time out of their day today to come join Jarrod and I as we talk about, this new innovative technology that Benesch is now using to utilize for their roadways and right-of-way kind of asset management, asset development. And there we go. Next slide. So starting off here, here's what the agenda is going to look like for us today. I'm going to do a brief little introduction about Jarrod and myself. I'm going to then get into Cyvl's technology, really focusing on how we're able to kind of develop this really high quality data sets for the sensors that we have. And then from then, Jarrod's going to take over. He's going to be talking about how Benesch integrates this new data into their current workflows and how they're using it with the municipality partners across the country at the moment. And then we're going to open it up to the field for some Q&A. If you do have a question during the meeting, during the webinar here, there is a chat box on the side. Feel free to write your questions as we go, and then we can kind of either field them at the very end and then kind of open it up to the rest of everybody else from there. There we go. And to start it off, my name is Jeffrey Greim. I am the sales manager here at Cyvl.ai. I kind of specialize in taking very complicated things and making them simple. So hopefully I'll be able to do that today for you guys at this webinar. Jarrod, do you want to give a little brief introduction about yourself?
Sure, thanks, Jeff. Hi, everybody. Jarrod Ruppel, I'm a project manager at Benesch, primarily in the bridge and asset management group, but I touched a little bit of everything from week to week. This coming June marks 10 years of my time at Benesch, so I'm glad to be a part of this webinar and joining Cyvl.ai.
Perfect. All right, so this right here was kind of the precipice of how the relationship between Cyvl and Benesch started. It began here with 10 citywide pilot project. Did some sample sets for these 10 cities, basic things like pavement analysis, the stress details of the pavement, then mapping about 5 different right-of-way kind of assets for these cities. Benesch kind of took that and was able to present these to the cities, verify the results from the data that we gave to them. And now we're kind of opening up that relationship and expanding with them more across the country instead of just regionalized here in the Kansas and Missouri area. And a little bit about Cyvl and who we are. In the very basic form, we help engineering firms and governments map, assess, and manage transportation infrastructure and networks at a citywide scale. Really what kind of makes us special is how we go about doing that. We have a little bit of a different spin than how it's traditionally done, and a little different spin for how the new ways of doing it is done as well. And this is probably one of the more important things of what makes us so special, is the fact we've developed our own sensor stack. So in the sensor stack, you have a mobile LiDAR system that's highly accurate within 75 feet. It's got a 3 centimeter accuracy rating within 75 feet. So if we say that a sign is 8 feet tall, that statement is within 3 centimeters of being correct. It also has high-res imagery for forward-facing, rear-facing, and a 360-degree camera on top as well. And then it has RTK GPS. Now, I didn't know what the heck RTK GPS was till a few months ago, but apparently how the best way to think of it is like your normal cell phone's GPS has about a 20-foot accuracy rating. RTK GPS is able to bring that accuracy rating down to about 3 feet. So if we say that a stop sign is at X coordinate and Y coordinate, that statement's within 3 feet of being correct. And really, how all 3 of these different sensors work together is really how we go about having the best and most high quality data results as a team. And this is really at the very simple form, the 4 of the main things that we do here at Cyvl. We give standardized pavement scores, whether that's PCI based or Paiser based. And then we're able to do pavement distress details, really understanding how those pavement scores are formed based on the different types of defects that are in the pavement. The type of defect, the location of the defect, the size of the defect, and the severity level of defect. So it's really highly interpretable results that we're giving you when we're telling you about your different pavement scores. Another big item that we do is pavement markings and striping, being able to map all the pavement markings and stripings for a town or city. And then really any right-of-way asset, whether that's a point asset or a line asset, such as like a signs or guardrails, anything that you can see from the streets, we're able to use our AI, go into those data sets and pull out that information for the projects that you have. And right here, you have a view of what a PCI-based analysis of a roadway system may look like. On the screen, you can see scores ranging from 0 to 100. We can also do Paisley-based scoring from 1 to 10. And you can see basically the color coordination, how well those roadways are. Some engineering firms are able to take this scoring alone and come up with great pavement management plans. Others want to get a more intricate detail of why these scores are scored the way they are. And we're able to provide that with what I mentioned before with these distress details. So we have all these different polygons overlaid over the roadway. Each of these polygons is representing a different kind of distress detail, a different kind of pavement distress. There's about top 18 total distresses what we're currently mapping right now. And again, we're going to be able to tell you the size of the distress, the type of distress, its location, and its low, high, or medium severity level. And then those kind of distresses are going to exactly correlate to the score that we're giving to those roadways. You can take those scores and those distresses, you can put them into whatever kind of software system you're using for your different asset management, whether that's like a cartograph or street saver, or if your own personal GIS. And this is really what kind of makes us special here, guys. It's the fact we're using two separate data sets and not just one. We're using imagery sensor and we're using 3D LiDAR sensors. So imagery alone is really good at kind of seeing certain types of defects in the roadway. Any kind of cracking, utility cuts, patching. Very good at putting AI to imagery and seeing those kind of defects. The problem though, when it comes to imagery is that it's 2D, it's not 3D. So seeing three-dimensional defects through imagery is very difficult. You end up missing a lot of them. That's where the mobile LiDAR comes in. Mobile LiDAR is able to see the rutting, it sees the potholes, it sees the distortions, any kind of like three-dimensional defects that are gonna be mostly missed from camera alone. That mobile LiDAR is able then to pick them up and kind of correct any of those wrongdoings from that imagery only AI scan. Also, things like shadowing that happen on roadways, very difficult when you're talking about imagery. If it can think a shadow is a pothole, it can think a shadow is like a crack, it can think it's utility patching. Having that second data set, that mobile LiDAR data set come in, it can then reassure, no, actually that's smooth pavement, there's no cracking there, there's no shadowing there, there's no utility cuts there. It's able then to kind of correct a lot of those false positives, which then creates a very high quality data set, one that's much more closely aligned with what a boots on the ground evaluation of a roadway may actually be. And to kind of give you a nice visual representation of that, here's a roadway with a mobile LiDAR scan. You can see on here a bunch of different like depressions, some shoves, and even down the center, you can see some rutting from the wheel paths, the car going down it. These are the kind of defects that a lot of these are going to be missed if you had imagery alone, but are able to be picked up because we have that mobile LiDAR as well. And like I said, in addition to just doing, roadway evaluations, we can do basically any other right-of-way mapping as well. So all your different lane markings, all your different assets that are along the roadways as well, we can automatically pick up. So instead of having to do 5 or 6 different projects, all doing different kind of data collections, you can do one drive-by. We can collect all that information, and then we can start pulling the results for all these different projects all at once. It's a huge time save for the partners that we're working with. Here we have a nice little list of about 20 different point and line assets that we're able to pull out for projects across the country. What's really great here too, guys, is even if your partner is just trying to do a basic pavement evaluation, we're still collecting this data. So a year from now, if he's more interested in doing some of these point assets, you don't have to go back and do a big rescan, because like right here, it's pointing at a manhole cover. Those manholes aren't changing over the course of a year. That data is still good. We can still go back into that historic data and pull it out at a pretty low cost, because we've already done all the heavy lifting on the first project with all the base mapping, putting all that together. And here's just some more examples of just some basic point assets we're able to then map for our engineering partners. Again, another one, very simple, it makes mapping any kind of right-of-way asset very simple for our engineering partners to then present to the municipality partners. And really, this is the simple 1, 2, 3 of it, guys. We have this great mobile LiDAR sensor. Our partners go out, they scan the whole towns, municipalities, cities. We then create 3D models. We go into those models, we pull out all the different kind of deliverables they might need for those projects. Then we present the data in a format that our partners are able then to digest and upload into their system and make their analysis on. And we're eliminating the need for going out multiple times, doing manual measurements of the roadways, and just doing one simple scan, cutting down the total time of projects like 10x, and be able to do more and more projects at once because of this. And here are the kind of the main benefits of our partners see when they're partnering with us on this. Automatically inventory assets from the same data. Instead of going out there with just one guy with an iPad saying there's a sign here, it's this kind of sign, and his takes 4 months to do one kind of asset mapping. You can map everything all at once. All the data can be processed simultaneously. You don't need to bring on additional staff to do all these new projects. The same staff can handle a lot more projects. It's affordable and it's incredibly scalable. Like if Benesch wanted to go out there and scan the entire state of Kansas, we could send them 10 sensors and they can accomplish it in a month, as opposed to taking, one sensor a year and a half. And of course, at the end of the day, the municipality partners are thrilled with the results that they see from us, whether that's from the really high quality pavement analysis we're doing, or something as simple as just having updated 360-degree images of the roadway, so they can go through and not have to rely on like the Google Streetcar that came through 9 years ago. And that being said, I'll pass it over to my friend over here, Jarrod.
Thanks, Jeff, and good afternoon, everybody who's tuning in today to the webinar. I'm glad to see we have so many people attending today. Before I dive into how we've taken advantage of Cyvl's innovative technology, I first want to provide just a brief introduction about Benesch and who we are. So Benesch is a transportation-focused civil engineering firm. We're headquartered out of Chicago, and we have 50 offices across 20 states. So we've been providing engineering solutions to our clients for over 75 years. And we've grown to 1,000 employees nationwide. And while we offer a large range of services in the engineering world, one area that we've grown particularly passionate about in recent years is in asset management. Now, the term asset management is something that we hear used in all sorts of applications, but at Benesch, we prefer to define that as using data-driven decision-making to address infrastructure needs through a proactive, risk-based approach. So I'll dive a bit more into that. There we go. So the diagram I'm showing here on the screen is kind of the typical flow of information from data collection up to an actionable asset plan. Now, when I described Benesch's approach just a few moments ago, one of the first things I mentioned was data-driven. And that's because the type and most importantly, the quality of the data that we use to create an asset plan is like the foundation of a building. So if a foundation is weak and unreliable, there's a really good chance that it'll jeopardize the credibility of the entire plan and everything moving forward. And this is why Benesch is dedicated to identifying innovative technologies and technology-driven project partners like Cyvl to deliver new and improved ways of collecting and analyzing this data. So Jeff kind of showed you some of the cool features of Cyvl's tech a little bit ago, and we're using this to really home in on the location and the type and extent of defects that we see in pavement and really other roadside assets. This information feeds directly into creating more effective versions of what goes into a thorough asset management plan. Some of those items are shown there in blue on the screen. Now, to get to this point, though, we need to first understand as much as we can about our infrastructure assets, including, what do we have out there? What condition is it in? How long do we think it's going to last? And ultimately, what do we think it's going to cost to replace all this stuff? From our experience, we know that this initial step, kind of the existing conditions assessment, can really be cumbersome both in time and cost. Jeff touched base on that earlier with kind of your traditional methods. It can be the victim of inspector subjectivity, and sometimes it's just plain inconsistent from different sources. So that's when our team started looking for a better way to collect data. There we go. So enter Cyvl.ai in our pilot program. Our team was really impressed with Jeff and the rest of the folks at Cyvl. And after a few video calls and making sure that our Benesch vehicle was properly equipped to mount their data collection rig, we were really excited and jumped at the opportunity for a pilot program. Now, this program wasn't something that we went to one of our clients and said, hey, we're going to do this. Will you help foot the bill? Can we sign into a contract? This was something that Benesch did out of our own pocket because we didn't feel it was appropriate, to test out workflows and navigate challenges with, some innovative tech on the client's dime. But, like I said, we were already sold on Cyvl's methodology of using AI to evaluate some of this field data. So it was really our goal to create what we call a sensor to software workflow. And this would document for future reference, not only for our division, but for other offices throughout Benesch, how do we get the process moving that starts with receiving and setting up that rig to collecting the data in the field and ultimately to exporting the data from Cyvl's online application that we feed everything into. So, of course, with any new process, there's going to be a few hiccups, right? Cyvl's team provided a great user manual to guide you step by step to set everything up, which you can see Troy and Chad there in the photo, smiles on their faces, just loving setting up that rig. But one issue we ran into with our fleet vehicles was the auto shutoff feature, which a lot of new vehicles have these days. So we'd pull up to stop signs or stoplights, and just that quick little power burst from the auto shutoff feature was killing power to the rig. Something that Cyvl, probably couldn't predict, something we didn't know what was going on. But after a couple of YouTube videos, we got it fixed, we got it shut off, and it was smooth sailing. So it's things like that we just want to document and include in this kind of best practices manual moving forward for Benesch offices. So some of the other items, we discussed with Jeff's team and documented in this document included some environmental factors to consider while collecting. So like in the fall, if you have leaves on the ground, or wintertime when you have snow covering up the roadway, since the rig, like Jeff said, is a LiDAR unit and not an X-ray machine, it has to have a clear line of sight to work properly. In some areas, like maybe busy downtown areas, we recognize that the actual weekday when you decide to collect can play a big role, because if you have cars parked along the road, during the workday, a lot of your view is going to be blocked. So on our end, maybe collecting on a weekend day when a lot of those cars aren't going to be there will optimize results in those situations. So beyond this best practices manual we developed, we realized that through this pilot program, when it comes to data collection, the future is now. So we no longer need to operate based on the old saying that, well, this is just the way it's always been done. Let's just keep doing what we've always been doing. We want to embrace a proactive approach that companies like Cyvl are taking, when they're carving a path to innovative new ways to incorporate technology into how we're doing business. And it's vital for us as consultants and engineers to keep that conversation flowing on future developments in this realm. So now that we have this great high quality pavement data, the question is, what are we going to do with it? How do we go from the exported and AI processed information into something that our engineers and our clients can ultimately tailor for their needs in asset management? So traditionally, Benesch has used Microsoft Excel or something similar to process this data and create plans. Excel is a natural starting point because, one, most clients have access and some familiarity with Microsoft Suite products, and two, we just couldn't really encounter a product out in the market that checked enough boxes for us to feel justified in investing in. So we were looking for a product that was functional to different data types. So as inventory data can vary greatly from asset to asset, kind of like PCI data on your roadways to NBI condition data for your bridges, we wanted something that didn't just try to shove everything into the same shaped box. We wanted flexibility in what we could import and manipulate. And in that manipulation realm, we wanted something we could tailor the analysis of. We wanted to incorporate items outside of just condition and geometric data. So we were looking for ways to incorporate things like traffic volumes, retro reflectivity, things in that realm. That's when we met with IDS and their asset optimizer software, AO for short. So AO is a cloud-based application, so it's not an installed piece of software on your machine. And it works with GIS integration, which is huge for us. So we can actually visualize our assets on an interactive map of the network. And you can really see how things change over a multi-year program. In addition to that kind of GIS mapping, we can do condition evaluations and prioritizations, import and create our own deterioration models. We can really customize our own maintenance strategies. And then also on the budgeting side, we can set levels from different accounts or funding sources. So all of those customized elements on the front end are then fed into AO's algorithms on the back end to create two types of multi-year project plans. One, the budget style plan, which is something we're all kind of used to. So we have a bucket of money. What can I do to my network with that bucket? And number two is a performance-based. So we have certain performance goals, certain strategic goals we're trying to hit with our network. What is it going to cost to get to that level? So that type of functionality, once you combine it with hopefully similar approaches in other asset classes, means you can start packaging together all these infrastructure projects into cross-asset bundles, and then really improve the cost effectiveness of our CIPs. So usually at this point is when I hear someone say, okay, Jarrod, this all sounds great, but I'm a pavement maintenance manager. I have enough on my plate with just my own data. I don't have time to worry about water lines or bridges or even departments outside of my group. Now, I realize that every organization, has independent departments that often stay within their own bubble. Not always does one hand know what the other one's doing in the same municipality. And staffing challenges that a lot of municipalities face these days has not made the situation easier. But in order to maximize the effectiveness of our time and our limited resources, we have to start looking beyond what's just in front of us. We can start down that path by asking other groups or personnel, how might they be indirectly, how might they be playing a role in our asset plans? Are there funding or financing methods that we can capitalize on if we start discussing programming strategies with our finance team? Or maybe there's some tips and tricks that our field operations staff have tucked away in their back pocket that can help with our maintenance strategy. Lately, we've seen a big influx of federal grant opportunities. Are some of those floating around that we can apply for and bring in, to our financing, our funding, to help bridge the gap and paying for all this work we want to do? So kind of taking a step back and looking how we're collecting this data, how we're leveraging it from a larger, more strategic approach and a strategic lens will really help to break down those departmental silos that we see in most organizations and hopefully lead to a much more strategic and effective management plan.
You need to go backwards, Jarrod.
Yeah, missed a couple slides here. Let me back up.
This one, right?
There we go. There we go. Perfect. Thanks, Emma. So to reiterate, guys, this starts all with improving our data collection. Again, strengthening that foundation of our building and shifting our approach and developing asset plans from a reactive to proactive state, right? So we're going to step away from doing data collection updates that are slow and cumbersome and maybe even still by hand. We're going to stop chasing our tail by doing only the worst first in our network and never truly catching up to hit our performance goals. We're going to strive to reduce inconsistencies in our budget forecasting and better understand what's coming on the horizon as far as funding needs. And then we won't develop these plans just to stack them on the shelf and never look at them again. Instead, we're going to maximize technology to streamline our data collection with all the latest tools at our disposal, like Cyvl.ai. We're going to identify when is the right time to perform the right maintenance activity by using this higher quality data. And we're going to start setting smart goals and objectives and hopefully have the tools to achieve them. And ultimately, we're going to treat our plans like living, breathing documents that we update routinely and maybe even approach other assets and bring them into the fold. So with that, I do want to touch base. One slide. There we go. So before I wrap things up, I do want to touch base on the KCK pilot program, Kansas City, Kansas. So in KCK, we targeted about a mile stretch of one of KCK's busier arterials. This arterial runs under an interstate. It goes through a handful of intersections. It has numerous local streets attached to it. We tried to choose a location that we wanted to include as many varying elements in this test environment as possible to see how everything would work. And we documented not only the pavement condition and defect locations, as you can see there on the screen, but also inventoried over 280 roadside assets, ranging from traffic cams, catch basins, streetlights, traffic signs. And this was just on a 1 mile stretch. And the collection time to collect all of this took about as long as it took for us just to drive down the road. We had very similar results to this in other locations, including the pilot program. Very efficient data collection, very streamlined. So beyond, just the pavement portion of this infrastructure management, which I think usually steals a spotlight in most of these situations, mainly because it's so much more expensive compared to other assets. It's easy to forget that how many other individual items, individual asset pieces we have throughout our roadway network. These municipalities have spent time and resources installing them, constructing them, and ultimately investing money, in these items. So even if we are going to develop a detailed plan, for each asset type, we're not going to develop a plan for all the traffic cams in an area, maybe all the trash cans or whatever it might be. Still, just gathering the knowledge and the data of what do we have out there can really help in the conversation we're trying to address of how can we collect this data more efficiently, and ultimately what can we do with it afterwards. So with that, I'll turn it back over to Jeff, and I want to thank everybody else for attending today.
Awesome. Jarrod, thank you so much. Yeah, I think just my talks across the country, you'd be just shocked to find out how many towns, cities, counties across the country just don't know where their assets are located. They know they're spending X amount of dollars every few years on, buying new signs, but they don't even know where their current signs are. It's really kind of eye-opening. And the fact of the matter is because the cost involved of the old way of doing it, sending out engineering teams one by one, saying where these assets are located. This new kind of way of doing this asset verification is changing the whole way that anyone's going to be going out there and doing this asset mapping. And that being said, yeah, any questions that we have from the field, I'm more than happy to answer it now, both Jarrod and myself. See here, I got my assistant Emma here. She's hitting some buttons on my screen so I can see potentially what we have. What's that? I'll go ahead and you can type away your any questions in the chat. Happy to answer it. Raise your hand maybe as well. We can help you that way. I know me and Jarrod did do an amazing job explaining everything, so there might not be as many questions from a typical webinar might see. Our fault. But yeah, of course. Oh, Levi, I really appreciate that. Doesn't have a question, but he's very impressed.
One of the things I've
okay.
seen about data collection for this kind of stuff has to do a lot with the speed of the vehicle.
Mhm.
Can you talk a little bit about how that works for your guys' stuff? I know a lot of other PCI radar or LiDAR stuff is really 20, 30 miles an hour max. Do you guys have anything like that?
Yeah, that's a great question. Yeah, there are some data collection requirements when you're doing the data collection. Currently, very similar to what you said, 30 miles per hour or less is the recommended speed, just so we're getting all the proper imagery. You want to obviously do it during the day. You don't want to do it when the sun's on the horizons either. You don't want to do it when it's raining. If it's raining out, you can get water droplets on the sensors, on the lenses, things like that. That being said, we have another generation, our next generation of sensor is coming out later this spring. The next generation is going to be at highway speeds. So there will no longer be that 30 mile per hour kind of limiting factor. You'll be able to drive up to highway speeds with our next generation of sensors. I do have a question here as well from the chat that says, if you do get shadows from parked cars, can you drive a second time and fill in the shadows? Yeah, I mean, I don't think shadows from parked cars are too big of an issue, overall. I think anytime that Jarrod did mention having cars in the street and things like that. I think typically, when you're doing these kind of data collections, there's not much of a difference between the manual inspection and this automated inspection in the sense that if there are cars in the street when you're doing the automated inspection, there will be cars in the street when you're doing your manual inspection as well, right? And I don't think many engineers are getting on their hands and knees to look underneath to see the pavement underneath the cars for every single car that's parked on the roadway, right? But the shadowing again, we have a pretty good solve for that with that mobile LiDAR as well. So yes, shadows do cause issues on imagery when you're applying AI to imagery, thinking that it's a utility patch or a pothole or depression or things like that. Having that mobile LiDAR secondary data set is able to come in and verify the fact that it's just a shadow and not an actual defect in the pavement as well. Give it another like 30 seconds or so if anyone has anything else they'd like to ask about this. And of course, my email there is there, Jarrod's email is there as well. More than happy to connect with anyone after this. Okay, can the AI differentiate the difference of the severity of an alligator cracking, like moderate, severe? Yes. So every single one of the like top 18 pavement defects, we're able to assign a severity level to it. And something like alligator cracking, it's not just gonna give it a severity level, it's gonna tell you the amount of area that alligator crack is also taking up as well on the roadway. So it's gonna say it's located at this location, X coordinate, Y coordination, it's taking up this much square footage, and it's a low, medium, or high level severity. And then all that data, that's one of the stress details, you can either feed that into one of your software systems, or it's highly correlated to the score that we're also giving to that roadway, that section of roadway, based on PCI modeling or based on Pazer modeling. And have you looked into creating terrain models from the data, such as a DTM from the roadway? So a digital terrain model, is that what you're referring to? I'm not the most technical guy. I know that we're basically able to give like these, I call it the rainbow road, these like topographic kind of surveys of the roadway, where you're able to actually see based on the color scale where the different high points are and low points are on the roadway. And that's really how we're able to see great things like rutting in the roadway where the tires go by. And you could import that topographical LiDAR into whatever kind of like Cyvl 3D program that you have. We're able then to provide you with that raw LiDAR assets as well for you too. But you know, that might be a question too, Levi, man, that I could forward over to one of our engineering team, and they can probably give you a more precise answer on that other than myself. Okay, we have another question here. Can accept an existing GIS data set, identify locations, and then record the data to match that data set and assign the pavement ratings per those segments? Yes, I'm gonna say yes on that. So basically, as long as it's gonna depend on the data sets that you're giving us, right? And then for us, we can then match that schema of data sets and then do a real easy comparison of the two. So if it says that there are signs or guardrails located in these locations, we can then kind of match that schema of that data set when we do our algorithms, and we can do a really easy kind of change detection between the two different data sets and make any kind of determinations of what might be different from the original versus what's here with the current set. And then of course we're going to have all the imagery files and bounding boxes to back up all the statements that we're making, and we can then kind of visually inspect and make sure that those two data sets are actually the results are what we're saying. Is the LiDAR data measurable? Like you can see a sidewalk, you can measure it. From that to get accurate width, or would you be done in GIS from an aerial? I mean, yeah, so the LiDAR system we're using, right? Like I said, it's highly accurate within 75 feet within that 3 centimeter accuracy rating. The problems you run into a little bit with sidewalks, guys, is parked cars, obstructions. You might not always 100% of the time have a clear view of the sidewalk. You're gonna have it probably 90% of the time, right? And from that, you are able to make, measurements of those sidewalks. And you can even do it right from our platform. We have a mobile LiDAR kind of page you can just click on and see the data and actually make the measurements directly from there. Yeah, but what we don't do when we talk about sidewalks right now, because the next follow-up question, I can anticipate it, would be, well, if you can do sidewalk measurements like that, can you do like ADA compliance on the ramps and things like that? We're not doing any kind of ADA ramp compliances on on sidewalk ramps. We can tell you where all your ADA ramps are located. But in order to get like a true ADA compliance, you would need to have survey grade mobile LiDAR. And what I mean by that is you're gonna need to have a mobile LiDAR system that's getting underneath 1 millimeter accuracy ratings on those measurements. Our measurements are within 3 centimeters within 75 feet. So we can't really give out those like, is this ADA compliant or not based on the measurements of the sidewalks, so as you're driving by. But we can tell you where they're located, and we can give you picture representation of it, and you can do a visual inspection if you'd like. Can the LiDAR be used for measuring slopes for curved ramps? Yeah, so I think I did anticipate the follow-up question there. So not really, that's not really what it's meant for, I'd say at the moment, but you know, that's probably one of the top questions that we get to, guys, right? And we're a company that's constantly developing, and we're constantly trying to think of what's the next big thing. And obviously, something as important as curb ramps and ADA compliance for sidewalks, we know that's very important for our customers. And it's definitely something that's on kind of the big board here of, you know, potential future projects for our company. Can the LiDAR be used to detect drainage issues? Like, yeah, I'd say, I mean, we'd love to work with you on something like that. We've had some questions about that before. We can definitely tell, you know, based on the mobile LiDAR of the roadway, where areas would be more susceptible to puddling. I think, you know, some sort of pilot, we'd want to run with you on that, just to kind of verify that the data that we're seeing is corresponding to the data you're seeing, and then we can kind of open that up at a larger scale for sure. There's definitely a high correlation between, you know, certain types of pavement defects and areas that would puddle, right? And right now, I think the best way to tell if there's puddling issues is to go and drive the roadways after it rains, right? All right. Yeah, you can't drive 500 miles after. Yeah, I know. I think really, like Steven, like to talk on that, like a good way to do it would be to, let's drive 50 miles after it rains, right? See where the puddling is, and then let's drive that after it's dried up and see if we can find the correlation between the two, right? And then say like, and then we can have some sort of potential like accuracy ratings for those puddling areas. We can say, you know, we scanned, you know, this 500 miles, and these, you know, 30 sections are the ones that our system is saying are most highly likely to have a puddling issue. You know what I mean? All right. I think we might be running out of questions, which is fine. And if you think of any more, like I said, myself, Jarrod, more than happy to kind of answer them. Tag us both in it because we were both in this webinar. I think you'd want to have eyes on it as well. That'd be great. More than happy then to run this back for you guys again. If you saw this and you want some other people within your company, within your municipality to kind of get a better understanding of it, me and Jarrod are more than happy to jump on a call with that as well. Okay, and I think with that being said, just want to thank everybody for taking the time today to join and learn more about Cyvl's technology and how Benesch is utilizing this technology for their municipality partners. We did record today's session as well. We'll probably be posting that or sending you each a copy via email, or check our LinkedIn. Most likely we might be posting it there as well. Jarrod, do you have any closing remarks from your side?
Nope. I appreciate everyone's attendance today. And again, like Jeff said, please feel free to reach out to either of us if you have any questions or want to know more. Thanks,
All right.
everybody.
Thanks, everybody. Really appreciate it.